Hello and welcome back to NTMAU. This can be found on page 203 in your practical math book, and it's a continuation of bisecting angles and working with bolt circles. So to begin with, what we know is we have 5 holes. 1, 2, 3, 4, 5. So just like the last problem that we had, what you're going to do is take 5 and divide that into 360. So let's bring up our calculator. And we take 360 divided by 5, and that equals 72. So that means that it's 72 degrees from here to here. Okay, 72 degrees. It would be 72 degrees here. It would be 72 degrees from this point to this next point if I had a line coming down here, and so on all the way around. So it would be 72 degrees from this angle to this angle, 72 from here to here, and 72 from here to here. Let me sketch that up and you can see better what it looks like. All right, I'm going to take this off and we'll take a look at it. Okay, so the way we would set this problem up is we know that we've got 72 degrees from here, 72 degrees here, 72 degrees here, 72 degrees here, and 72 degrees here. 5 of 72 degrees equals a full 360 degrees. Then what we're going to do is break this angle down, or bisect this total 72 degrees by dividing it in half. So 72 degrees divided by 2 gives you 36 degrees. And it tells us right down here that it's given that AD equals 7.62 centimeters. Don't worry about centimeter to inch. It doesn't matter. Numbers are numbers. We're not going to even pay attention to this at all. Don't pay attention to the centimeter piece. So we just know that this is 7.62. That's the distance from here to here. Now what we're going to do is we're going to divide this by 2. So we know that we have 3.81 from here to here, and we have 3.81 from this point to this point. All right? Now what we're going to do, or what this is saying, is they want to know what this diameter is, what the distance would be if we could draw this line straight down to the center point and then continue it so that it would go all the way down. And basically what that means is that you're bisecting the angle twice, so you would have the angles inside here. Okay, and what that means then is if we would draw this like this, and we would draw this like this, this inside here would be exactly like that there. But what we're looking for is the straight line distance all the way down. All right, and to get this, we know that we're going to be working with, or at least trying to find out, what the hypotenuse is. And we know it's the hypotenuse because there's our 90 degrees. It's the longest side. The hypotenuse is always 100% of the time directly across from the 90 degrees. So you have to go for what you know. And remember, the one on the top is the one you're looking for. So the hypotenuse is the one that you're looking for. And the one on the bottom is the one that you have. And you have the opposite side, opposite of 36 degrees, okay? So our formula is going to be hypotenuse over opposite, and it's going to be what? We know it's going to be the cosecant. Remember, it's opposite of what we were looking for. It's a complementary angle. Why? Because we don't have, it begins with, oh hell, another hour of arithmetic, which is the O over H, and then A over H, and then O over A. Let's take a look at that again, just to refresh your memory. So this is what it looks like. If you remember, we had the oh hell, another hour of arithmetic, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then just the way that your calculator is set up, the sine is your first key, the cosine is the second key, and the tangent is the third key, working from left to right. Now, this problem says we're looking for the hypotenuse. The one on the top is the one you're looking for. The one on the bottom is the one that you have. I can't tell you that enough times for you to remember. So here's what we're looking for, or here's what we have. We have the 3.810, or 3 inches, 810 thousandths. That's the opposite side. And we have 36 degrees. So write this all down, pause your video, write it all down so that it's on there, and then I'll show you the calculator functions in order to solve for this. Okay, using the calculator on your computer, you would plug in 36, that's the 36 degrees, and then hit the sine key. It's not the sine that we're looking for the opposite of the sine, which is the cosecant. So we're going to hit this here, and I'm sorry. All right, again, the 36 sine, you're going to hit the complementary angle of the sine, or the complementary function, not the side, but the function, and that means you're going to hit the 1x key. That tells you that the cosecant of 36 degrees is 1.7013. Now, I know the book has it set up a different way. They divide. I don't like to divide, and the reason why I don't like to divide is because if you put one number in front of the other, in other words, you put the numerator in front of the denominator or the denominator in front of the numerator, depending on which one of the two are supposed to be placed there, you could reverse the numbers. And rather than to reverse the numbers, multiplication, just like addition, doesn't matter which one you add first or which one you multiply first, it comes out to be the same. So this is just the way that I do it. If you're comfortable with using division, the way they show you in the book, that's fine, but that's not how I do it. I always use multiplication whenever I can and addition whenever I can. So, okay, we come up with 1.7013, and I hit the multiply key, and then I'm going to plug in this side over here, or this distance that we had over here, which I believe was 3.81, and we come up with 6.4189. That's going to be the distance from here to here, and then what we want to do is multiply it times 2. So times 2 equals 12.96. Now let's see how close we get that to the book. And you can see that it's the exact same thing, exact same number, just that we went about it a little differently because we used multiplication. But our 12.9639 is the same as their 12.964. They use division here. I don't like division, I use multiplication. I hope that helps, and I hope you're able to understand how we do these. And again, in any of the complementary angles, be it that you're looking for the complementary angle of sine, which would be the cosecant, the complementary angle of the cosine, which would be the secant, or the complementary angle of the tangent, which would be the cotangent, you just have to hit the function key and the 1x key, and that pops you over to the complementary function. Okay? Thanks, and have a great day. See you on the next one.